Okay, so we are very quickly going to go through the combustion of methane, and we're going to be counting the atoms that are in the reactants and in the products. Okay, remember methane is a gas that is actually in farts and it can burn, okay, meaning that it reacts with oxygen in the air. Okay, so here we have our methane, which is CH4. Okay, and it reacts with oxygen in the air to produce CO2, which is carbon dioxide, and H2O, which is water. All right. We know that the number of atoms that we have of a certain element on the reactant side should equal the number of that element that we have on the product side. Okay, so let's do carbon first. Let's look at the reactant side. Okay, so I'm looking through for the C, that is the symbol for carbon, and I only see one C. Okay, whenever I'm calculating this for C, okay, there's an implied 1 behind it because it doesn't have a subscript, so that means it's 1. And it also does not have a coefficient, so it's, again, an implied 1. Okay, we're always going to take our coefficient times our subscript. In this case, it's both an implied 1, so we'd have 1, which is our coefficient, times our subscript, which is also an implied 1, and we would get a total of 1 carbon on the reactant side. Okay, then for hydrogen, we're going to look through for our H's. Look, we have an H right there. It's got a subscript of 4 and an implied coefficient of 1 out in front. Okay, so we take our coefficient out in front, so 1 times our subscript behind the H, which is 4, and we get a total of 4 hydrogens on our reactant side. Okay. Okay, now we're going to do oxygen. Okay, there's no oxygen in this first molecule, but here's an oxygen molecule here. Okay, so what this is saying, the O has a subscript of 2. That means that every molecule of oxygen has 2 oxygen atoms in it, which can be kind of confusing. Okay, but there's 2 atoms in each oxygen molecule, and then there are 2 molecules of oxygen. Okay, so again, we're going to be taking our coefficient times our subscript. So we've got 2, coefficient of 2, times our subscript of 2 to get a total of 4 atoms. Okay, now I could cheat and I could just write over on the product side the answers that I got, because we know that our reactants, the number of atoms that we have in our reactants, should equal our products. Okay, but we're going to check ourselves. All right, so looking at carbon in the product side, we're looking for our C's. So we got a C here. Okay, there's no subscript, so it's an implied 1. And there's no coefficient, so that also means it's an implied 1. Okay, so we've got our coefficient of 1 times our subscript of 1. And again, we get a total of 1 carbon in the product side. So it matches up. That's good. Okay. Now we need to do that for hydrogen. Okay, so I'm looking through for my H's, and I see here's 1 here. Okay, we've got a subscript of 2 and a coefficient of 2. Okay, so I'm going to take 2, my coefficient of 2, times my subscript of 2. Okay, and in total, that means that I'm going to have 4 hydrogens present. Okay, so I've got 2 hydrogens for each molecule of water, but I got 2 molecules of water. So in total, 2 times 2, that gives me 4 hydrogens total that are produced. Then, lastly, oxygen. Okay, so I'm looking for my O's, and this is kind of confusing because there's more than one. Okay, so let's deal with the O's in this first product first. Okay, so we got an O here, and it has a subscript of 2 and an implied coefficient of 1. Okay, so we got 1 times 2 to start out with. 1 times 2. And that tells me that there are 2 oxygens in this first molecule. But there's also some oxygens in that water back here. Okay, so we are going to have to add them together. Okay, that's what that plus sign in the middle means. All right, so we've got this O right here, okay, with an implied subscript of 1 behind it. So we're going to take our 2, our coefficient of 2, times 1, and we get 2. Okay, but then we got to add the 2 and the 2 together, and that gives us a total of 4. And look, they all balance out. Good job.